is transmitter and receiver with encoder and decoder. The transmitter and the trigger, there are two modules that we will just see. Two modules, four switches, two ICs. One is encoder IC, one is decoder IC. Those circuits we will do it to understand what is communication, what is RF communication. Okay, so we'll jump into the practicals. All right, friends. So we'll start our practicals on RF and encoder and decoder. So you can see here, I've kept two circuits. I've made two circuits here. You can see. So one by one, I will just explain you. Then we will see the demo of this. Okay. So I will just explain you about the first circuit. That is this one. This is encoder circuit. So I remove this and I will put this circuit. Now you can see here there is a IC integrated circuit is there, right? You can see a IC over here. This is encoder IC. There is one module here, right? This is called as RF transmitter module, right? Transmitter module. The receiver module is this side. Okay, the receiver module will be on other side. So this is, we are discussing about transmitter. That is this transmitter module, which works on 5 volts. Even this IC works with 5 volts. Okay, so I will just give you a little idea about the IC. What is this IC? So HT12E, E represents encoder, right? It is an 18-pin IC. You can see 9 pins on both the sides. It is a CMOS IC. Okay, it has 2 serial encoder. We call it as a 2 serial encoder also. Okay, right? Can transmit up to 12 bit of data, right? This IC can transmit up to 12 bit of parallel data. So you please remember, this is an encoder. That means if any information from this switch, suppose I press this switch, one end of the switch is connected to ground, okay, and another end is connected to the IC pins. That is pin number 10, 11, 12, and 13. These are the 4 pins where I've connected the switches. So naturally, when I press one of the pin becomes low. That is 1 bit of data, it is going to low. The same amount of data, it is mixed or rather encoded here in the IC, and then it is given out from pin number 17. This is pin number 17. From to this jumper, it has come to the input of the transmitter. Okay, this is the transmitter part, and this also works with 5 volts. So I've connected 4 switches. Please remember, pin number 1 to pin number 9. It is all connected to ground. Okay, pin number 10, 11, 12, 13 is your input, and pin number 15 and pin number 16. There is a resistor you can see here, 1 mega ohm, which works like an oscillator. It requires an oscillation. That is 5% of the value. It has to be there. So we have to take this as an oscillator. Okay. So again, pin number you have say about 15, 14. Sorry, 14. 14 is again grounded, and you can see. So as circuit we have connected it. Okay. We have just I shown you a circuit before. So according to that we have connected. Now we'll discuss about this circuit now. This is decoder. Okay. This is a decoder IC. Yeah, here we can say decoder IC. Same specification like 12E. E is encoder, and this is decoder. Okay, there is a notch, pin number 1, and pin number 1 starts from here, which goes to the ground, and last pin number 8, right? That is your VCC supply. Okay, this red color jumper. In this case also, in other IC also, it was same. Okay, so here also we have used a value. That is here in that case I have used this receiver side. I have used a 33K resistance. There I have used 1 mega ohm resistance. So same connection. Where the encoder, the input were there in encoder, here we will take it as an output. Output I have connected 4 LEDs, right? You can see 4 LEDs here, which are connected through one resistor to ground. Okay, and this is all pin number 1 to pin number 9. It is all ground points. Okay, so encoder, and this is your receiver. Receiver has an antenna. I have connected a small wire here. In transmitter also we can connect wire. Why? Because if you put antenna, the distance, right? Distance will be more. I have also used one IC here. This is a regulator IC, because I'll be giving 9 volts. So I will not give the 9 volt directly to this IC or to the circuit. I want the 9 volt should be converted to 5 volt. So 5 volt regulator IC, I have used it here. That I'm going to connect. Now I will show you the demo, right? I hope you understood this circuit. Already we have planned the circuit. We have seen the circuit. I will just connect the circuit, and I will show it to you. How does it work? Right. Okay. I'm given connection to one side. That is receiver side I have given. And this is a transmitter side. What I will do is I will give connection through my power supply. I have a power supply here that is directly 5 volts power supply. I will give 5 volt power supply from there itself. Okay. Now you can see here all the lights have come on, correct? All the lights have come on, right? You can see, probably you can see all the lights have come on. Now what do you do? What does this light indicates? I have just kept this light so that when the frequency is generated here and it is transferred through RF, through antenna, it comes over here. So this will indicate whether my frequency is coming or not. If this light doesn't come, there is no communication between transmitter and the receiver module. This is your transmitter module. This is our receiver module. So there is no communication. So now there is a communication because this light is coming. Okay. Now what I will do, I will press one switch here. You can see here one light has switched off. So it's a reverse light. We can do it. We can put a transistor and we can reverse it. Now it is on, it will be off, and when you press a button, it will be on. So any device can be connected to this. I'll put another switch. You can see another light switched off till I press it, then I remove it, right? So we can use any type of switch, permanent switch. This is bell switch I'm using. Please remember, this is the other one, right? Okay, we'll try this also, right? So you can see I can control the four LED or four outputs through this RF. This, what is this circuit? The circuit is called as RF remote. You can use for so many purposes. What you have to do is you have to remove this module and replace with another module. Please remember here I have used 315 megahertz. You can use 433 megahertz or any other frequency. Two type of modules you get in the market where the frequency can be adjusted, right? Or this thing, how it can be adjusted, because the trimmer will be there. You will find a trimmer. You can see here, I'm just putting my here. This is the trimmer. So you can adjust the values here. But usually we use fixed frequency. So to remote Troyes and RF frequency, remotes, you can make so many projects with the help of this. Okay, please check this. Okay, I hope you understood this particular project. Thank you.